name is Adam Gilfillan, and I am a student from NC State University. This screencast is part of my final project for my Computer Science 510 class on software engineering. The focus of this screencast is on the JavaScript source code analysis tool, Plato. A link to Plato, as well as all other references, are available in the description below. Plato is a much-needed tool for the JavaScript developers of the world. As popular of a language as JavaScript is, for example, it ranks number 1 by the number of repositories created on GitHub in 2013. It has only a small handful of useful static source code analysis tools. JSLint is one of the most popular of the bunch. Let's check it out. JSLint is simply a web tool available at JSLint.com that accepts copy and pasted JavaScript code. Here I copy and paste some Plato JavaScript source file, and then returns errors, bugs, and best practice advice about the code you submitted. While useful in its own right, this is really the only tool that JavaScript developers make use of regularly. Other languages that have been around for longer, such as C++ and Java, have much more extensive static source code analysis tools and a plethora of options to choose from. Plato attempts to rectify the limit of options JavaScript developers have. As a recap, in my previous blog post, I wrote about what I learned about the open source code that I ran Plato on. You can find information on that at my blog, adamgilfillan.wordpress.com. I gained some interesting insight about many large and small projects, and it is worth checking out if you haven't already. Link can be found below as well. And in my previous podcast, I briefly covered how Plato works, as well as delving into what I learned about the actual tool, Plato. In this screencast, I will dive further into detail of how Plato works. I will even run through a short demo of using the tool from start to finish. So Plato is essentially a visualization and investigation tool that wraps together two tools, JSHint and JSComplexity. I will explain later how each of these tools work, since they are the essence of Plato. Plato works through the node command line interface. Once you set your command, Plato simply reads your JavaScript source file and then creates a report on it. This report is this HTML file that you can open in your browser to view. So let's try it out. So first, to get Plato running, you need to make sure that you have Node.js installed. You can find Node.js at nodejs.org. Node.js is essentially a platform for developing applications through JavaScript on server side and client side. I won't really go into how to install it, but it's pretty simple. Download it, install it, and you can then install Plato through the Node.js command line interface. So once you've downloaded and installed Plato and Node.js, you're ready to begin. First though, you need to make sure you have a JavaScript project that you would like to run Plato on. I've gone ahead and downloaded a project from GitHub called Gmaps. Gmaps is a wrapper project for Google Maps. It essentially makes the Google Maps API easier to use. I just went ahead and downloaded the zip file from GitHub, and I won't bore you with those details, but that's all you have to do. So now we're ready to begin. Let's go ahead and open up a Node.js command prompt. And I've already created that folder where I have my Gmaps. I'm going to go ahead and navigate there now. I believe I called it. So now that you have your JavaScript source project that you'd like to run Plato on, we're ready to begin. Let's go ahead and open a Node.js command prompt and navigate to where you downloaded or stored that project. I believe I stored it in a folder called sample Plato. Yes, okay. We can see what options Plato has by just typing in Plato and pressing enter. We have help, quiet, version, exclude, directory, recurse, JSHint, title, and date. The main ones here to use are -d for directory. That's where we're going to put our file. our report rather, and -r for recursively checking our entire project files. So let's go ahead and run this. So we'll just do a simple Plato R and D. Let's name it our folder report. Let's give it a title. Let's call it my Gmaps report. And the name of the file is Gmaps master. Let's go ahead and run it. Looks like it can't parse some of the JSON files, but that's okay, and it says it's done. So let's go ahead and take a look at it. So as you can see, that was really quick. Let's go ahead and find that folder where it's located. I have this folder open here now, my sample Plato folder. There, it's created our report folder. You get a whole bunch of different items, folders, files here, but the one we're really interested in is our index.html file. And there it is. Here's our Gmaps report. We get a nice summary of our project. Let me just zoom out here so we can see it a bit better. It gives us our source lines of code, our average lines of code. We get a maintainability score. This maintainability score is, as you can see here, is a value between 0 and 100 that represents how easily maintainable the project is. Through many times of running Plato on various large and small projects, as I went into on my blog post, I've never seen a maintainability score over 80 or under 50. So I think 67 is a pretty good maintainability score. You also get some of this maintainability score on every single JavaScript file, as you can see. Markers.js, native extensions.js, yada yada yada. Each one has its own score. As we scroll down here, we see the lines of code per file. We see the estimated errors in implementation. Now, back to how I was saying that Plato is a combination of JS complexity and JSHint. JSHint is what's giving us this estimated errors in implementation. I'll go more into that here soon. It's also what is giving us the lint errors. We get kind of a summary here of our files. We can sort each file by the highest complexity, the highest number of source lines of code, estimated errors, and so forth. If we scroll back up here, we can investigate each file individually. Say we're interested in looking at this gmaps.roots.js file. With a simple click on that, we get a file view with its own maintainability score, its difficulty. Now this difficulty is interesting. I'll go more into that here in a minute. But it's essentially a value measuring how hard it is to write the file or to understand it. We also get some function details on the file, as you can see by complexity and by source lines of code. We can even, as we scroll down further, see the entire source code of this file, and we get information about the actual functions of the file. So if we hover over one of the function names, we can see information such as the complexity, length, difficulty, estimated number of bugs. This information is useful if you're really trying to delve into and investigate a certain project. So yeah, this is Plato. And with a simple press of the back button, we can go back to our main Gmaps report file and further investigate anything that we would like to. So I mentioned before that Plato is essentially a wrapper for two other tools, JSHint and JS Complexity. Let's go ahead and take a look at JSHint. JSHint is just found at jshint.com, and it works a lot like JSLint, like I showed earlier. You can just copy and paste some code. I put in some code from our Gmaps project, and you can find some complexity information, such as climatic complexity, and some other useful things. It's worth checking out. But Plato does a really good job of visualizing this and getting more useful information rather than just using jshint.com. So this is JSHint. Let's go ahead and take a look at JS Complexity. jscomplexity.org. JS Complexity is a lot like JSHint and JSLint, you can copy and paste some code. Let's do the same code, and you can analyze. Here you'll get some useful information back, but if you look at the information it's giving back, it's essentially the same information that we saw in Plato, and this makes sense because Plato is a wrapper for JS complexity and JSHint. Plato does a much better job of conveying this information since it's not just in text format. Let's go ahead and take a look at what this information means. If we go up here to the About complexity, we kind of get some information and rundown of what the lines of code means. That's pretty self-explanatory. The cyclomatic complexity, just a brief information about this, is defined by Mr. Thomas McCabe. Kind of looks at the number of cycles or number of run-throughs or loops that a program goes through in a flow control graph. The lower the number, the better. Plato also makes use of this Halstead complexity measures. So these numbers were developed a while ago by Mr. Maurice Halstead, and they're metrics that look at a number of different things. Here are the metrics. It looks at difficulty, volume, and effort. All these numbers go into what makes Plato useful. Here's also the maintainability index. This maintainability index takes a look at basically a summation or an average of everything. This metric is a formula that uses the average of three other metrics as input. It uses the Halstead effort measure, the cyclomatic complexity, and the lines of code, and returns a number from -infinity up to 171. Plato alters this number to be on the scale of 0 to 100, and like I said before, for my own testing, I have yet to see maintainability greater than 80 or even less than 50. And that ranges on projects from sizes of 150 lines of code up to 250,000. We can kind of look at some other interesting things that JS complexity gives us, but Plato doesn't really make use of some of these dependencies or change cost metrics. So now that we kind of understand the metrics a bit better, let's go back to our report that Plato created for us. And here we see the maintainability, lines of code, errors. All these metrics make a bit more sense to us now. We can kind of see how Plato is without a doubt an impressive visual web interface. It visualizes the useful features from JSHint and JS complexity. We are able to investigate single files and learn information about our functions on just a single file, and gain useful information on just about anything that we would want from our JavaScript file and project. I hope that after viewing this screencast and my entire project here on Plato, many more people will be interested in Plato as a useful JavaScript status source code analysis tool. To see the tool for yourself, head on over here to GitHub and search for Plato, or follow the link in your description. Thank you for your time.